Good afternoon and welcome to the new Count on Us. We have a new and exciting, fun, fabulous show for you this afternoon. My name is Coach Sun here with one of our new, amazing, talented coaches.
I am Coach Young. Welcome.
Yay, and welcome to Coach Young. We are so excited to have her with us. So this new Count on Us is really exciting because we are here to help show you that math is fun and math makes sense.
Yes.
And all the different ways to solve math problems and problem-solving strategies. So we are really excited. And how can we do that, you ask?
Good question. Well, our new format includes hands-on learning activities, take classroom visits that allow you to be right on the air with us, fluency game challenges, as well as the homework live questions that you are going to be bringing to us this afternoon.
Awesome. And just so you know, and it looks like we might even have a few callers ready, but the phone number here to call us here at Count on Us is 301-772-0080. I also see on your screen just a moment ago, and it will be back. We have some really exciting news. We have a math night at McDonald's for Count on Us coming up tomorrow. Tomorrow. It is at the McDonald's in Riverdale at 5600 Riverdale Road, and it is from 5 to 7 o'clock tomorrow night, and there will be a lot of the hosts and the talent and people involved in Count on Us there with you doing games. There'll be food, prizes. It'll be really exciting. So we hope to see many of you tomorrow night at the McDonald's in Riverdale from 5 to 7 o'clock p.m. It's going to be really, really awesome.
Yes,
and we
come
hope to
out
see you there.
and have fun with us.
Yes. Awesome. So we also have some segments that are really awesome. Do you want to tell us about one of those segments today?
Sure. Our next segment is actually a tape classroom visit, I believe, from Princeton Elementary School, and they had a great question for us. Let's take it away and see what the question is.
Let's see.
Hi, I'm Joseph. Hi, I'm Lamar. And we're from Ms. Cannon's 5th grade class at Princeton Elementary School. And we would like to have help on multiplying and dividing fractions.
Hi, so that was a great question from Princeton Elementary, and that's one of the new segments that we love here at the new Count on Us, is that we are asking students across the county and across the district what questions they have so that we can help address any of those questions.
Yes.
So they were asking about multiplying and dividing fractions, and there are a lot of different ways to show you how to multiply and divide fractions. We also have multiplying fractions by whole numbers, multiplying fractions by other fractions, and the same with dividing. Today we are going to show you one example of each, and if those students are out there and they still have some questions, they can definitely call back later in the show.
Yes.
So we're going to start with multiplying fractions by whole numbers. So let's say, for example, we are trying to multiply 3 times 3/12, excuse me. So what we're saying is, what would 3 groups of 3/12 be? So let's say we have 3 pizzas, and each of those 3 pizzas has 3/12 left of that pizza. So we want to know what it would equal if we had 3 groups of those 3/12. So what we're going to use here is some fraction tiles, and each of these is 1/12. So 1/12, 1/12, 1/12 comes together to make 3/12, and we did 3 of those groups. So if we have 3 of those groups, we can actually put all of those together, and what we will see is that we have now 9/12. So there are 9/12 of a pizza left, and if we wanted to, and if you have fraction tiles, and we can talk one of these days about making your own fraction tiles, which is really cool, because 3/12 actually is equivalent to 1/4. So what this actually equals to is 3/4. So that's an example of multiplying fractions by a whole number. And let's say we would like to divide fractions by a whole number. So let's say we have 1/5 of something, and we want to divide that by 2. So let's say I have 1/5 of a chocolate bar left, and I want to share that between 2 people, and I want to know how much would each person get. Well, what I'm basically doing when I'm dividing by 2 is I am breaking it apart into 2 equal parts. So I want to look to see if I have my fraction tiles, what 2 pieces can come together to make 1/5, and the 2 pieces are each 1/10. So if I have 1/5 and I divide it by 2, each of those pieces would be 1/10 of that chocolate bar. So 1/5 divided by 2 equals 1/10. So we really appreciate those students from Princeton calling in with that shout out. And if they have further questions about multiplying or dividing fractions, or anyone else out there does, please give us a call here at Count on Us. The number is 301-772-0080. And it just so happens, this is so exciting, we are feeling the math love today. We have callers, and we are ready to get to it. So let's see who is our first caller for today. Good afternoon and welcome to Count on Us. How are you today?
Hello?
Hi, how are you today?
Good.
Good.
Who are we speaking to?
Xavier.
Xavier, welcome to Count on Us. Is this your first time calling Count on Us?
No.
No. Well, we are so excited that you are calling back here again. And who is your teacher? Which school do you go to, and who is your teacher?
Hillcrest Heights Elementary School, and my teacher is Miss Young.
Ooh! Yes! All right.
Oh, that's so exciting. How cool is that? That you get to call Count on Us.
Hi,
And
Xavier.
see your awesome teacher here.
Okay, so what's your question?
The equivalent. What is the equivalent fraction to 0.88?
0.88.
So we want to know. You might be better at writing on that side.
Okay, so
Here we go. We're doing equivalent fraction. Your teacher has much better handwriting than I, so we're just going to take turns. So we want to know, what is an equivalent fraction to 0.88? Is that
Yes.
correct? Can you tell me how you would read this decimal?
What's the correct way to read that decimal?
0.88.
I want you to think place value now. How would you correctly read it using place value? The correct term.
Think about your plate. Are you there? I'm sorry, Xavier. Go ahead. Are you ready to answer, or do you want some help with that part of the question?
The answer: 0.8800.
88 hundredths.
88 hundredths,
So
correct.
you just read that nicely, and you said 88 hundredths. So if I just said to you, can you write a fraction that is 88 hundredths, how would you write that fraction, Xavier?
88 out of 100.
Exactly.
Excellent.
Oh, my pen, my pen, my pen. There we go. Thank you, Coach Young. So actually, when we are talking about decimals that are equal to tenths or hundredths, it's really easy to write them into an equivalent fraction, because then we can just write that fraction over tenths or hundredths. And actually, I'm going to ask you, Xavier, to stay tuned, because in a little while, we are going to have a mini lesson that actually talks about equivalency with tenths and hundredths. So we're going to ask you to stay tuned to that, and that will hopefully give you a little bit more help with that, okay?
Okay.
Thank you
Thank
so
you for
much
calling.
for calling, Xavier. We appreciate it. Did that answer your question?
No.
Oh, okay, I'm sorry. Did you have another part, or would you like to see it visually, or is there another part?
No, there's no other part.
Was it from like a question that you had on your homework, or you were just asked? What's that?
A question on my homework.
Okay, and what were the directions? Just to write an equivalent fraction? Okay. And if you all haven't done simplifying fractions, I don't want to go into that. Have you done simplifying?
We haven't touched it yet.
Okay. Okay. So there you go. Now, if you want to, one thing, well, I don't want to spoil the mini lesson. I don't want to spoil the mini lesson, but we're just going to show you real quick, and I want you to actually think about this, and everybody out there in Count on Us land, if you could think about this. I want you to think about, normally we think about this as a 100 block, and we use it with hundreds, tens, and ones, but we can actually also use them to represent decimals. So I want you to think about, and maybe we'll come back to this if we have time. If this is equal to 1, let's say this is equal to 1 instead of 100, what would 88 hundredths look like on there? Okay?
I want you to think about that.
So think about that, and we'll come back to that if we have time later, okay?
Okay.
All right, have a great day, Xavier. We appreciate it.
You too.
Okay, thanks so much. Take care. And we have another caller.
All right.
Loving this math love today. Good afternoon and welcome to Count on Us. How are you today? Is this, I don't want to say your name wrong, Lesage? Oh, Amari. Amari, are you there?
Hello?
Hi. Is this Amari?
Yes.
Hi, Amari. How are you today?
Good.
Wonderful. And can you tell us what school you are calling from and what grade you are in?
I'm calling from Philippine Master Academy.
Wonderful. And what grade are you in?
Second grade. Second.
Second grade. Who's your teacher?
Miss Davis.
Oh, Miss Davis is the best. Please tell Miss Davis that we said hello from the Count on Us coaches, okay?
Okay.
Okay, wonderful. So what's your question that you would like help with today?
Subtraction.
Subtraction? Okay. Do you have a specific subtraction question that you would like help with?
Yes.
Okay. Go ahead. Miss Young, Coach Young, do you want to write? Okay, perfect. She's much better at writing. You'll see it much better. Okay, go ahead, Amari.
20 minus 15.
Was it 40 or 20? I'm sorry, 20 minus 15?
Yes.
Okay. And do you know what we actually maybe could use? We have an exciting manipulative of the week, which we're going to talk about a little bit more, but let's go ahead and use some.
Okay.
Can we?
So we're going to use our base 10.
Okay. Do you want to talk through it and I'll manipulate?
So here we have our 10s, and we want to represent the number 20, so we take out two 10s. So we have 10, 20.
Sorry.
And now we want to represent 15, so we have 10 and 5 ones. 1, 2, 3, 4, 5. Okay? So now we want to take away 15 from our 20. So how will we do that? Well, we will take this 15 away. So we have 20, take away 15.
Sorry. Here we go. We can actually maybe do this if we need to. Is this helping right here? Okay, hold on, I'm coming.
So what we're doing is we're actually making this our 10s into ones, okay? So that it will make it easier for you. So now, here we have.
Sorry. Okay.
In total, when we want to take 15 away, we have 20 altogether, and then now we can take 15. So, sorry,
Yep, 15
10,
is 1 10 and
1,
5
2, 3, 4, and 5. So, how many do we have left?
How many are left, Amari?
Huh?
Okay, so let's try this. And we can actually show you as we're doing it over here at the same time. Did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say we have our 20 here, and we can show you over here at the exact same time. So what we want to do is we want to take our 5 ones. We want to take our 5 ones away first, but when we look at the ones in 20, we don't have any that are separated. So what we did was we kind of traded this 10 for 10 ones right here. So then we can actually then take away 5 ones. So what we did was, I'm sorry, do you want to mark it up? Okay. So instead of 2 groups of 10s, we actually have 1 group of 10 and then 10 ones. So we can write that over here, and we made that fair trade so that we can then take away 5 ones from 10 ones. So then we could take away 1, 2, 3, 4, 5. And it looks like we have 5 ones left.
Yeah.
And then we can take away 1 group of 10, and it's really only 1 group of 10, so that means there are 0 groups of 10. So there are our 5 ones left. So 20 minus 15 equals 5. And what we did was, if you don't have enough ones in your top number when you're subtracting, you can make that trade with your base 10, okay?
Okay.
Okay, thank you so much for calling, Amari. We truly appreciate it. Have a wonderful day, okay?
Okay.
All right, and we have, let's see, who is next? Is this Mercedes? Was that correct?
Yes.
Hi, how are you, Mercedes? Welcome to Count on Us.
Welcome.
Are you a first-time caller?
Yes.
We gotta do some cheering for our first-time caller. Awesome. We are so glad that you have joined us here for Count on Us. Thank you so much. So, what can we help you with today? Well, I guess we should start. What school are you calling from? And what grade are you in?
I am in 2nd grade, and I go to Samuel P. Massey Academy.
Wonderful. And who's your teacher?
Miss Davis.
Oh, Miss Davis. Her class is in the house today. Awesome. And what can we help you with today?
63 plus 22.
60, what is it?
63 plus 22.
Okay, wonderful. So what we're going to do is we are going to bring back out our base 10 so we can show that. Now when we are adding them right now, I'm going to write it, we wrote it both ways here so that we can, sometimes you will see it horizontally and sometimes vertically. So if we want to show the number 63, how many 10s and how many 1s are in the number 63, Mercedes? Do you know how many 10s and 1s are in 63? Are you there?
3. 6 10s and 3 1s.
Excellent.
Excellent. So, Coach Young is going to show us 6 10s and 3 1s.
1, 2, 3, 4, 5, and 6 10s.
Perfect. So there's our 6 10s. I'm just going to move it over here because I think we're a little, there we go, and 3 1s. So can you see the TV screen, Mercedes?
Yes.
Does that look right to you?
Yes.
Okay, wonderful. So in the number 22, how many 10s and how many 1s?
2 10s and 2 1s.
Perfect.
Excellent.
2 10s and 2 1s. So does this look correct to you?
Yes.
Awesome. So if we are adding, what can you tell me about adding? What are we going to do with these two numbers?
We can add them together and count by 10s to add them up.
Okay.
Excellent.
Yeah, we can. And when we're adding, what are we doing with those numbers? You mentioned adding them. So when we're adding, what does that mean we're doing with those numbers?
We're counting them.
Okay, we're putting them together. So what we're going to do is we're going to put together our 1s first. And actually, we can put together our 10s first and just count them in a moment. So if we put our 3 1s with our 2 1s, can you see how many 1s we now have?
Yes.
How many 1s do we have?
5.
Excellent. Now let's look at our tens. We had 6 tens and we had 2 tens. So let's count them together. Are you ready?
Yes.
Here we go. 1, 2,
2,
3, 4,
4,
5,
5,
6, 7, 8. So how many tens do we now have?
8.
We have 8. So if we are adding 63 plus 22, how many do we now have? How do we read that number?
85.
Excellent,
Excellent job.
excellent. 85. So these base 10 blocks are awesome to help us add and subtract. And actually, in a little bit, we're going to talk about how you can make a different version of these at home, which is really awesome, so that you can have them at home. Thank you so much for calling, Mercedes. We appreciate it. Okay, so
Calling on in.
I love these calls.
Yes.
I love these calls, and I love all the math love out there. So let's go to another caller. Who do we have? Is this Michaela on the line?
Hello.
Hi, how are you
Hi.
today?
Good.
Good. Welcome to Count on Us.
What school do you go to, Michaela? And what grade?
My name is Audra.
I'm sorry,
Audra. Sorry. Hey, Audra, how are you?
It's really good.
Good. It's good to hear from you, Audra. This is my first time on the show this year, and I've missed Audra because Audra is an awesome frequent caller. So it's nice to hear your voice, Audra. Okay, so
Thank you.
So would you like to tell us what grade and what school?
I'm in 4th grade and I go to Malton Elementary School.
Okay, wonderful. And what would you like help with today?
Today the topic is about multiplying fractions by whole numbers.
Excellent. And we just had some fraction strips
Yes.
out. Okay, so do you have a specific problem you would like help with?
Is it okay if I have 2 problems?
Well, let's start with 1 because we have some other callers. And then later, if you want to, you can call back and see if we have some other callers because we do have a few other callers on the line. So if you could pick just 1 to start with
Okay,
and then
that's
call back
okay.
later. Okay? Okay.
Okay. The question says, the question is 10 times 10 over 12
Okay. So 10
equals.
10 times 10 twelfths? Is that correct?
Yep, that is correct.
Okay. Now, what do the specific directions say? Is there a way that they would like us to show this answer?
The directions say solve each problem, answer as a mixed fraction.
Okay. By whole numbers. Okay. So, is there a certain way that you have been solving this in school? I'm going to try to find some twelfths while you talk to us about how you solve this in school.
Our teacher, Mr. Berkeley, told us to put the whole number over 1 and then multiply it by 10 twelfths in this situation.
Okay, so let's see how many twelfths I have here. I'm not even sure here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. I need one more 12. Here it is. So, do we agree that this right here is equal to 10 twelfths? Do we agree with that?
Does this model represent 10 twelfths?
Can you hold on so I can count it on TV?
Okay, so what we're saying is, basically, if we're multiplying this by 10, and I'm not actually sure if you saw the students call in from Princeton Elementary. We did a similar thing, but we were multiplying it by a smaller whole number. So basically what we would be doing, and let me maybe move this up a little bit, is we would actually be just showing this 10 times. So if we're doing 10 times 10 twelfths, that means we're basically doing 10 twelfths 10 times. So we would do 10 twelfths, And then
I
we
have a
do this again,
question.
another 10 twelfths, and we would do another 10 twelfths, and we would do another 10 twelfths, and we would keep going, and we would do this 10 times. 1, 2, 3, 4, 5, 6,
I have
7.
a question.
Yes. Don't mind my
Will
sloppiness.
you put the 10 over there, or are you just going to multiply it like how you multiplied it?
So what I was hoping to do, it would just take us a while to make this 10 times, is to show you why that works. So it sounds like what you were doing is if you were doing 10 times 10 12, you talked about putting the whole number over 1, and then what would you do? What would you do next?
I learned that we should do the numerator first, so
Do what with the numerator?
times 10
So 10 times
equals
10
100.
equals?
Correct.
Mm-hmm.
Can't let me.
And then what would you do?
Then you would multiply the denominator.
Correct.
Correct? So what would that be? 1 times 12 equals?
12.
Exactly. And what I was hoping to do with all this is show you why that works. Because when you're multiplying, these are still going to all be twelfths. You're just doing 10 twelfths 10 times.
Be a proper fraction.
What's that? It's a little hard to hear you.
It's supposed to be a fraction.
Improper fraction.
Oh, okay. Or a fraction greater than 1. But let me just explain this really quickly. The reason why this works and what we did
that is
works
fine.
is that if this was 10 twelfths and we did it 10 times, it would be 10 twelfths, then 20 twelfths, 30, 40 twelfths, 50 twelfths, 60 twelfths, 70 twelfths, 80 twelfths, 90 twelfths, and 100 twelfths. I actually wrote it 10 times. So that's why this multiplying across works. Because when we're talking about all these groups of twelfths, the size of the pieces doesn't change, but we're saying how many more pieces there would be. So that's why this 100 twelfths actually worked. Each of these 10 twelfths is represented by this. Okay, and the direction said to keep it.
As
I'm sorry, Audra, it's just a little hard to hear you. Go ahead.
we have to write it as a mixed number.
Say it one more time, Audra.
Fraction.
What's that, Audra?
We have to write it as fraction.
Oh, you need to write it as a mixed number? Is that correct? Okay.
Yes.
Okay, so what we're going to do is we are going to see how many times 12 can go into 10. Do you know 12 times what that gets us as close to 100? Excuse me. 12 goes into 100 how many times without going over? Okay, so we have 12
Can you
times.
repeat that?
So we're seeing how many times 12 can go into 100 without going over. We know that 12 times 10, it would be 120. That's too many. So we could try, let's say 12 times 8. Let's give that a try. 2 times 8 equals 16.
Okay.
1 times 8 is 8. 1 more is 90. And that seems as close without going over. So 12 goes into 100 8 times. That would be our whole number. The difference between 96 and 100 is there would be 4 that are not accounted for, and our denominator would stay the same. So 100 twelfths as a mixed number becomes 8 and 4 twelfths. Okay? Thank you
for
so
calling.
much for calling, Audra. We appreciate it. Stay tuned at the end of the show when we pull names from the treasure chest. Everyone that's calling, and I don't know if we even had time to mention this, but everybody that's calling gets their name in the treasure chest. And then at the very end of the show, we pull a name from our treasure chest because we treasure all of our callers. And that winner will get a surprise prize at their school. So we know that there are a lot of callers. We're going to take one more caller before we go to break, and we promise we'll get to everybody before the end of the show. So Michaela, welcome to Count on Us. How are you today?
Good.
Hi, Michaela.
Would you like to tell us about yourself? Where do you go to school and what grade are you in?
Second.
Second grade.
Can I take a wild, wacky guess? Michaela, is your teacher Miss Davis at Samuel Massey?
Yes, I am from Samuel Massey, but my teacher name is Mr. Brown.
Oh, I'm so sorry. Look at what happens when you take a guess. Well, thank you so much for calling, and I am glad that we have lots of different callers from Samuel Massey.
Yes.
Very exciting. So what can we help you with today?
Measurements.
Okay. So what is there anything in particular about measurement?
Yes. So today I will be asking you, so say if you have a type of tree, any type of tree, but you measure it from 1 all the way to 53, but what if that's not the answer?
It was hard for us to hear. I'm not sure if anybody in the back heard. It looks like measurement on a ruler. Is that what you're talking about?
Yes.
Okay, so let me try to find a ruler here. And what exactly were you trying to measure from a ruler?
Any type of tree or something.
A tree with
3?
Yeah.
Okay, so maybe going from, or we might just have to, here, oh my, look at this. It just pops up. Although we might, here we go. So it sounds like we have a ruler right here. And were you saying maybe to go from 3 to something else?
Yes.
Okay.
What, you're trying to go from 3 to what?
What number?
To 50.
Oh.
You're trying to go from 3 to 53?
Yes.
And you want to know how far that is?
Yes.
Okay.
But really what I'm trying to know, is it centimeters or is it inches in one of them?
Or is it maybe millimeters? Does it say in the question in front of you?
Yes.
Fabulous. What is it? What does it say?
It says in inches.
Okay, so we're gonna pretend that this is what a ruler really is, in essence, is a number line. And it just depends on which unit of measurement you're using, whether you're using millimeters or centimeters or inches. So if you're going from 3 to 53, since this ruler that is 1 foot goes up to 30 centimeters, and we're talking about inches, so it really only then goes to 12 inches. We're going to have this be a longer number line to show 3 to 53. Does that make sense?
Yes.
Okay. Would you like to do this, Coach Young, or you want me to do it? Totally up to you. Okay. So let's say we're starting at 0. Okay?
Okay.
And let's just count by tens for a little bit. Okay?
Okay.
Okay. 10, 20, 30,
40,
50, 60. Now we could keep going, but we don't need to keep going. This arrow shows that it keeps going in each way, and I was able to stop because what number are we actually trying to get to?
50.
50 or 53?
53.
Okay, I just wanted to make sure. So if we're trying to get to 53, and this is not the most perfect ruler here, but we're going to go, and normally in between each of these we're going to have 10 spots. So it would be 51, 52, 53, 54, 55, 56, 57, 58, 59, and then 60. So when we're talking about this ruler and we don't have time to do that, there would be 10 smaller spaces within each of these counting by tens. So if we started at 3 and we want to jump to 53, then we can actually, I'm going to mark this, we're going to count by tens, okay?
Okay.
Does that sound good?
Yeah.
Okay, and here we go. So what I actually did, because it's 3 after each base 10 numbers, we're going to start at 3, and then 10 more brings us to what number? We're going to start 3, and then that's going to bring us to 13. And then we're going to go another 10. And that's going to, that's going to bring us to 23. And then we're going to go another 10. And that's going to bring us to 33. Another 10 will bring us to 43. And another 10 will bring us to 53. So what we did was we were actually able to count by tens starting at 3, and that brought us all the way to the number 53. So let's take a look at how many numbers we counted. We counted by tens. So we counted by 10, 20, 30, 40, 50. So to go from 3 to 53, we actually went 50 spaces. And it would depend on which unit, whether it was inches, centimeters, millimeters, whatever unit it was. You went 50 of those units from 3 to 53. Does that make sense?
Yes.
Okay. Now, can I just say, Coach Young, how awesome the Math Love has been. And we are continuing to feel it. We know that we have people waiting on the line on the other side of the break. So please, please stay tuned, because we will be right back on the other side of the break. Stay tuned.
Grab your snack.
Snack?
Yes.
Snack!
I'm Dr. Mearshaw. I'm the principal of Largo High School, and I want to introduce our medical assistant program. It's been in place for 3 years, but this is the 4th year, and our seniors are getting to go into their 4th year using this wonderful new facility that was just finished and made ready for them.
Being a part of this academy is really beneficial for me, just knowing the fact that once I step outside the classroom, I'm definitely in a comfortable environment and able to help anyone that needs help in the medical field.
I did not know I wanted to be a physician until I got to be in this academy, and just knowing that just completes my life.
And I built a homemade portable charger by using a cracked open USB car charger and a 9V battery.
Hi, my name is Madison. I go to CMIT South and I'm in the 6th grade. I made a lunchbox alarm to keep my brother out of my lunchbox.
My name is Sam Kamara. I'm in 6th grade, and I made an outdoor FPV racing drone. The term FPV stands for first person view, where these goggles come in. So if I put this on, I can see what the camera sees.
Parents. It's safe to say that the start of the digital age, and specifically the internet, smartphones, and social media, have brought unique and dangerous challenges to the current generation of parents.
As a bonus challenge, the technology that both helps parents and also poses danger to our kids' safety is ever-changing.
The best way to face these parenting obstacles is to educate yourself about them, and we're here to help with that.
Talk openly and often about online safety with your children.
Install safety monitoring software on their cell phones, like Norton Family Premier.
Phone Share for Android will definitely help monitor all cell phone activity.
Limit screen time and designate specific areas for internet use.
Establish clear rules and safety principles.
Stay up to date on social media and online trends. It's always a good idea to sign up to monitor what's new and what apps kids are using.
For more information, visit us on the web at www.pgcps.org or call 301-952-6384.
Second half, because we're a little bit further than second half. Yes. The second part of the new Count on Us show. My name is Coach Sun, here with my awesome partner,
Coach Young.
And we are so excited that you are here with us. And we have a lot of callers, so we are going to get straight to those callers.
Yes.
Okay, welcome to Count on
I'm here with my awesome partner, Coach Young, and we...
Oh, it sounds like you might have the TV on in the back because I can hear ourselves. So can you do us a favor and just mute the TV and still talk to us through the phone, okay? Are you there? Is it Tishera? I'm not sure if I'm saying your name right.
Hello?
Hello?
Hi. Welcome to Count on Us.
Hi, how are you today?
Is it Tishera? I'm not sure if I'm saying your name right.
Tishera.
Tishera, welcome to Count on Us. Can you do us a favor? Can you please mute your TV? I can hear us in the background, so we're getting a little bit of feedback, okay?
Yeah, I'm just in front of my computer.
Oh, okay, I got you. Okay, wonderful. So what can we help you with today?
I just needed help on my my classwork from Miss Britt. She's my math teacher, and we're working on finding the greatest common factor.
Okay. Wonderful. And we're so glad that you have called us. Is this your first time calling Count on Us?
Yes.
Awesome!
Oh, welcome!
Yay, first time caller! Woo! Okay. All right, now that we have finished the cheering section of Count on Us, so do you want to take this one, Coach?
Sure.
All right.
So
the numbers that we are finding the greatest common factor of is 24 and 32.
Okay.
24 and
32.
32, gotcha. Okay.
So we have...
So what we're going to do, it looks like Coach Young is doing what's called the Texas T. And the Texas T,
I'll take one of those.
according to our producer, is how one way to, an easy way, I think, to check and make sure you have all your factors listed. Do you want to tell us how to do the Texas T?
Sure. So we're going to think about all the factors that we have to get 24. All right, so let's start from 1. We have 1 and 24 because 1 times 24 gives us 24. We have 2, so the factor that matches with 2 would be, can you tell us?
2 times 1 equals 24.
24.
2 times?
No.
12, correct. Okay, 3, and what can give us 24?
3 and 8.
Correct, excellent. What about 4? 4 times what can give us 24?
6.
Correct. How about 5? Anything for 5?
No.
All right, and then our next number would be 6, which we already have shown right here. So we're done finding our factors for 24. What about 32? Let's go over to 32.
I know 1 and 32.
Excellent. Mm-hmm. What about 2?
8 and
2.
6 and
Well, we know that 30 can break up in half to 15 each, and then we can just divide up those other two, so it would be 16.
All right. What about for 3? Anything for 3? With 3, any factors for 3 and 32?
No.
All right. 4?
4 and 30. That would be 4 and 8.
Correct. 5? Anything for 5?
No.
No. What about 6?
I don't think so.
No. What about 7?
No.
All right. So now we see that 8 is where we will stop here. So now, between these two, what is my largest number that I have that are shown in both models?
8.
8.
Excellent. Good job.
So 8 is your greatest common factor.
Excellent. Good job.
Fabulous. Does that help?
Yes.
Excellent. Doing those Texas T's really help because you can make sure you're getting each of the factors, and then you can look at both and see which is the greatest common factor you see. So hopefully that helped you as well. And your name is going into the treasure chest, so stay tuned at the very end of the show, and we will pull a name, and we will see if your name comes out of the treasure chest because we treasure all our callers. Thank you so much. Have a wonderful day.
Bye.
All right, take care. And we have more callers lined up. This is so awesome. Okay, good afternoon. Welcome to count on us. Who do we have with us today? Is this Marcus?
Oh, yes.
Hi, Marcus. How are you today?
Hello.
And what school are you calling from, Marcus?
I'm not at the school. I'm at my house.
Okay. Well, what school do you attend?
Huh? Hello?
Yes, hi. What school do you go to when you're not at home?
I attend Tulip Grove Elementary.
Excellent. And what grade are you in at Tulip Grove?
Third.
Awesome.
Third grade.
Wonderful. Okay. And what can we help you with today, Marcus?
It's like I'm on my homework.
Mm-hmm.
And like I'm trying to do some time elapsed. Kind of like that.
Okay.
So like it says that at 9:55 a.m. Daniel's class starts working on math. The class works on math for 45 minutes. Next, the class reads for 45 minutes. After reading, the class goes to lunch. At what time does Daniel's class go to lunch?
Okay. So we started at 9:55, and then we heard, you're coming through really clearly, and I appreciate that. I apologize that I think, was there two? Can you read it one more time so we can make sure to get all the information?
Wait, you want me to read it one more time?
Yes, read it one more time, please.
At 9:55 a.m., Daniel's class starts working on math.
Okay.
The class works on math for 45 minutes.
Okay.
Next, the class reads for 45 minutes.
Okay.
After reading, the class goes to lunch.
Okay.
At what time does Daniel's class go to lunch?
Oh.
Okay. So there are a lot of different ways to solve this. We can use a number line. We can use an actual clock. We can.
Want to try the clock?
You want to try the clock? Okay. So we're going to do the clock, and if we have time, we might be able to show you on the number line as well. So if we were to show 9:55, this is one of those ones that goes with you. So let's see, where would our hour hand be if we were showing 9:55? So here's 9 o'clock, right? And then we're going to count by fives. Count by fives with me. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So right now this is showing 9:55. It looks like it's almost at the 10 because it's very close to 10 o'clock, but it's not there yet. So what we want to do is we want to figure out what was 45 minutes later. And you know what we're going to do? We are going to do two things at the same time because that just sounds like fun to me. Okay. So let's say we started at 9:55. Do you want to write, Coach? I'm sorry. It's going to... Okay, so now what we want to do is at 9:55, we want to see what 45 minutes later looked like. Okay. So what we're going to do is we can go by 5 minutes up here. We can go by 5 minutes down here. Let's do the... Oh, my goodness.
We can do it simultaneously.
We can do it simultaneously. Is it just me getting excited about this? So let's do this in 5-minute increments. And then let's see what time we get to. Okay, I'm just making a lot of lines to prepare myself because Coach Young and I are going to do this at the same time. Okay, so let's count by fives until we get 45 minutes later. Are you ready?
Okay.
Okay, so here we go. We got 5, then we got 10,
10,
15,
15,
20,
20,
25, 30,
30,
35, 40, 45. Now what I would have liked to do, but I didn't have time while we were doing that, is actually write the time as we were going. So 5 minutes later would be 10 o'clock, and then 10 minutes later was 10:05, 10:15, 10:20. I just can't write as fast as Coach Young was going. But this is, if I am counting this correctly, right? 10, 5, oh. This is what happens when I miscounted by 5s. I'm sorry, everybody. 10, 15, 20, 25, 30, 35, and then 10:40. So 45 minutes later, we ended up at 10:40. So this is at the end of math. Now we're going to do the same thing, and we want to go 45 minutes again to show the reading block. Are you ready?
Yes.
Okay, here we go. We've then got 5.
5.
10.
10.
Keep going.
15.
Keep going.
20. 35. 25.
Good.
30.
Yep.
35. 40.
Yep.
45.
Excellent. So let's see. We stopped at 10:40 for math. So 5 minutes later would be 10:45, 10:50, 10:55. 5 minutes later would be 11 o'clock. 11:05. 11:10. 11:15. I'm going to look up in a minute and see if I match Coach Young. 11:20. 11:25 is at the end of our reading block. Does that match what Coach Young has?
Yes.
Awesome.
So what time did you actually go to lunch?
At 11:35. 25?
25. Excellent. And what we actually ended up doing between math and reading is we actually counted 90 minutes from when we started, because we had 45 minutes for math and 45 minutes for reading. We did that on the clock, which you can always draw a clock at home. That's fine. We also could do it along the number line, so I thought it was just neat to show there's always more than one way to solve a problem in math, and that was a nice way to do that. So hopefully that helped, Marcus. We really appreciate you calling.
Thank you for calling in.
Is in the treasure chest, so stay tuned. In about 8 minutes, we're going to pull a name from the treasure chest, okay? All right. We have one more caller because they love math.
Yes.
And math is awesome. And hopefully on this show today, everyone has enjoyed the math we've been doing, and we have a few more minutes. Okay, are we ready? All right, Morgan, are you there?
Hello.
Hi, Morgan.
Hello?
Hi.
Call back, Morgan. We lost you there.
Okay, and while we're waiting until Morgan calls back, we do have a few minutes. Did you want to talk about the manipulative of the week?
Yes, so our manipulative of the week are our base 10 blocks. And so these are things that you can actually make at home if you do not have base 10 blocks at home. So you can simply represent your ones with beans, something as simple as beans that are lying around your house, and popsicle sticks. So your popsicle sticks will actually be represented with your 10. So you can simply glue on 10 beans individually on your popsicle stick so that you can represent 10s. And then to represent hundreds, what you can do is glue your 10 10s together to make 100, and that way you can do so many amazing things, such as adding numbers, subtracting numbers, even representing fractions and decimals. So many things that you can do with your homemade base 10 blocks.
So one day, maybe on one of the next few shows, we'll actually have some made for you and we can show you. But that's really, really a cool way to have base 10 blocks at home. Awesome. And do we have our caller back? Morgan, are you there? Okay. So, do we have time for a mini lesson or maybe not? We're checking because we're getting close. Do we have time for a mini lesson? If not, do we have time we could think of a challenge of the day?
Sure.
Let's think of a challenge of the day. So what were some things we've done today? We've done multiplying fractions by whole numbers. We've added. We've subtracted. Elapsed time. So do you want to pick one of those for a challenge today?
Let's do, we can do greatest common factor.
Greatest common factor. Go. Okay. So we are going to go to trivia today. Great. You want to go with greatest common factor?
Sure.
Okay, so what two numbers would you like to find the greatest common factor for?
Let's go with, say 12 and 48.
Woo! All right. So today's trivia is, can you find the greatest common factor for 12 and 48? So if you have time to do that for today's challenge, what you can do is actually work on that at home. And the first caller that we get back here before the end of the show will be our winner for the challenge. And then separate from that, okay, and Morgan is back, but that's separate from our treasure chest. Okay, Morgan, how are you today?
Hi, Morgan.
Really good.
Good. All right, welcome. We have just a few minutes, so let's get right to it. What's the question that you would like us to help solve?
So I'm going to work on two-digit multiplication.
Okay. All right. Go ahead and give us the problem.
23 times 14.
Okay. So what we're going to do just based on time, and this would be a super fun thing to do with our base 10 blocks, but we are short on time. So what we're going to do is we're going to break this up into partial products and multiply it real quick. I just love partial products. I can't help it. So what we're going to do is we're going to multiply 4 times 3 and 4 times 20. What is 4 times 3, Morgan? Okay. 12, good. And due to time, I'm just going to go through it, okay? Then we want to multiply 4 times 20. Actually, that's in the 20s place, and the 10s place. 4 times 20 is 80. Then I'm going to go ahead, I'm going to multiply my 10 times my 3, which is 30, and my 10 times my 20, which is 200. So what that's doing is that's showing all the values of when I'm multiplying. So we have 2 plus all those zeros is 2. 8 plus 3 is 11, plus one more, excuse me, is, 12. And then 1 plus 2 is 3. So multiplying that out as super quickly as possible came out to 322. And I know that was so fast, Morgan. I'm really sorry. But hopefully you were able to see how we did that. Did that make sense how I did that?
Yes.
Okay. And partial products to me is a really nice way to see the meaning of what we're doing when we're multiplying. And that can always be done as well with the base 10 blocks like Coach Young mentioned, okay?
Yes, but Miss, I just want to say one thing.
Yes.
Miss Young is my teacher, and yes, I understand, and yes, I know y'all had to go really fast, but thank you, Miss Young, for calling.
All right. And thank you so much for calling. Isn't it cool to see Miss Young on TV? She's awesome. Yes. Okay, so here we go. Is there anybody that was able to call with today's challenge? Okay, well that was pretty quick, today's challenge. So do we have time for mini lesson, or we have time for a caller? We're seeing line 3. We're gonna go real fast. Line 3. Who is this today? Is line 3 still there?
This is Audra.
Audra, hi.
And the question to the trivia question is 22 and 3.
It was the greatest common factor for 12 and 48.
Is it 22 and 3?
No, sorry, Audra. Sorry. But we thank you so much, Audra. We really appreciate you calling with that today's challenge, and we really appreciate everyone who has called today. I want to take a moment to say thank you to Coach Young.
Thank you for having me, Coach Young.
Let's give Coach Young here. Do not forget about McDonald's night tomorrow.
Please come out.
At the McDonald's in Riverdale from 5 to 7, where you can meet a lot of the coaches from Count on Us, do math games. It's going to be a lot of fun. So 5 to 7 o'clock tomorrow. Don't forget, you can always stay tuned. Count on Us is on Mondays and Wednesdays now from 5 to 6 o'clock. Sorry, let me shake. We're going to do a shake with our treasure chest because we treasure all our callers. So let's see who is going to be our treasure chest winner for today.
Today, our winner is
Audra from Marlton Elementary. Congratulations, Audra.
Congratulations.
And thank you so much to all the callers out there. We loved having all the calls today. It was really phenomenal showing the math love out there. So stay tuned. On Wednesday, we will be back from 5 to 6 o'clock. And we have Xavier who just called in with today's challenge. So Xavier, congratulations. You are today's challenge winner. So that is awesome. congratulations to Xavier.
Yes.
And Audra, thank you so much for joining us today. Don't forget that you can always count on us. Have a great day, everybody.